Hello everyone, welcome back to the next video. In this video I will show you how to do object detection using TensorFlowLite with CameraX. So let's get started. So firstly I will show you guys the output. So here is my real device running, and if I try to move it in front of my laptop, here you can see, I'm not sure if it is visible to you or not because the background is also white, but at the very top you can see that it is displaying some number along with whatever object it has detected. So suppose if I try to detect some other object, okay, it is not able to detect anything. Let's see this. Okay, this is not neither a person nor a cat. Still, I mean, it is not 100% perfect because it tries to do object detection locally, but you get the point, right? Like for most, here you can see for the laptop it was able to detect properly, or if it is a bottle, I guess this should get detected. Okay, it is okay. Here you can see it is getting confused between bottle and vase. I'll just move it over here. Okay, it is telling it is a vase, but it is also telling it is a bottle. Now if I go over here and if I just press on this take photo button, so I'll just zoom out a little so that my box is perfect. Okay, now if I click on take photo, here you can see it has paused. It did took the photo, and in the toast message you can see the URI for where the photo URI of the photo. If you go to your external directory, you should be able to see the photo being saved. If you want to display the photo, you can use coil library to display that particular photo. But if I press this button again, here you can see it has again started detecting. So if I press the button again, it stops detecting, captures the photo, and if I press the button again, it starts detecting again. So that's what we will be doing. So let's get started. So firstly, as you can see, I have created a native Android application. I am using XML layout, but if you want, you can use Jetpack Compose as well. So here I have taken our build.gradle.kts. Okay, and I think I have added too many libraries. I don't think we require all this. Let's just see, do we require this? So firstly you will require camera core, camera 2 as well as camera lifecycle, and for TensorFlow we have to add this TensorFlowLite GPU as well as TensorFlowLite.support. Now all these libraries are referenced inside libs.versions.toml. so if I go over there, here you can see that for TensorFlowLite and TensorFlowLite support I have added this version, and this is okay. I think I got some error, unresolved reference. Okay, so I guess in build.gradle. We require this particular thing as well. So if I click on sync now, because I don't want to include this unnecessary dependencies which we have inside our project, it will just increase the size of our APK. Okay, I'm just building it again just to see. Sorry about this. Okay, so I think this is working fine. So you would require so okay, my app is building fine. Okay, so here you would require this view as well. So make sure you add this. You don't require this video, you don't require this extensions as well. Okay, now if you go to libs.versions.toml, here I was telling you I have added this TensorFlowLite as well as TensorFlowLite support. Here I have added camera core as well as camera 2. Okay, so add whatever version is the latest at the time of you watching this video. Then if you see, we are not using this, so I'll just remove this. And here inside libraries I have added camera 2, camera core. So you will have to add all this stuff. Just add all this stuff. And here I have added this camera lifecycle as well as camera view as well. And here I have added TensorFlow. Okay, just a second now. Okay, TensorFlowLite GPU as well as TensorFlowLite support. So okay, camera 2, yeah, so you will have to add all these dependencies. So once this dependency has been added, make sure you just click on sync now. So here TensorFlowLite has been added. Okay, and here camera 2 and camera core has been added. Yeah, now just click on sync now. Then what I have done is that I have gone to our activity underscore main. Firstly, to display the camera preview, I am using the preview view. I have added occupying the entire width and height. Then I have taken one image view to detect. So once I click on the button, you were able to see the like we were just pausing that particular preview, right, and displaying the image. So for that we are displaying this image view. Also, once we capture the image, the captured image won't contain that bounding box or the text view which I was showing. It will only capture the image. And here you can see this is the text view which displays what it has been detected, and this is a normal view for the bounding box, and this is the capture button. Now I'm also using this shape underscore rectangle for our this particular view. So just to draw that bounding box inside drawable, I have created this XML file and I have created this particular thing. So you can just copy paste it to draw the bounding box. Next, inside main activity, firstly I'll show you the imports. So these are all the imports which you can copy paste. Okay. Next, I have created object for viewfinder, text prediction, box prediction, as well as image predicted, then a bitmap buffer as well, and lens facing, whether it is front facing or back. Now I haven't added one more button for this, whether you want to switch front or back, but if you want, but I have added the code. All you have to do, just add one more button, and if you want to change it to front camera, you can do that as well. Next, I have created one image capture. I have created one executor. Pause analysis is false, image rotation degree is 0, and here we are creating our TF image buffer. Now you will also require those TensorFlowLite models. So for that, you will have to go to this particular URL and you can download this TensorFlowLite model. So one is labels text, as well as second is our TensorFlow model. Download all these files. If you want to use your own TensorFlowLite model for object detection, that's fine as well, but you will require these two files, like similar two files. Okay, and here if you see, I have created one assets folder, and here you will just have to copy paste your files over here. Okay, next I have created this TF image processor. Now to be honest, I'm not really sure what is happening, but it is mostly like image processing stuff. So I have just copy pasted this code. Even this code I have copy pasted here. I think we are initializing our TF light lazily, and here we are initializing our detector lazily. Then this is the input size for our TF. This will be called once we request permission for camera as well as external storage. So for that, you will have to go to android manifest.xml. make sure you add this hardware any feature, and for permission we will add camera permission, and write external storage will be only up to 28, because this is required for saving that photo to external storage up to 28, but about 28 it is handled automatically by CameraX. We don't have to worry about it. So here you can see, so once the permission is given, that we are requesting for multiple permission, as you can see over here, both permissions are granted, then only we start our camera. And inside on create, we are firstly initializing our all views, and if permission is granted, then we start camera, otherwise we request permission. On click of the button, we call this take photo method. So if you see, if analysis is paused, then we make it as false, and we like hide our image view. If it is if pause analysis is false, then we make it as true. We create a matrix. Now even I am not really sure what all these things are going on. Here we create an upright image, and this is the logic to save the photo. So here we create our image capture. This is how our image namings goes like, and here you can see we are creating our output options, passing it to our image capture. If image saved successfully, I'm displaying a toast message, but this is the URI for the image save. So you can use this URI to display the image inside an image view as well if you want. Next, for starting the camera, again this is boilerplate code which I have copied from CameraX. So first we require this camera provide future. We add a listener, we create a provider, we create a resolution selector as well, then we create a preview builder, and then an image capture, then an image analysis as well. and here again I'm not really sure what this is, all this stuff is, but I think it is trying to analyze each and every frame. So this is what it is. Okay, so you can just copy paste it. Even I am not really good at this. I have copy pasted this code from documentation. So this is all the code that is, and here if this lens facing is for front or back camera, whatever you have triggered, and this is for report prediction. So here you can see we are changing our box prediction layout params depending on what has been detected, and this is for mapping output coordinates. Again, sorry about that, I am not really sure what exactly is happening, but this is mostly boilerplate code which you can copy paste. And this is for requesting permissions. This is for all permissions granted. One helper method which I have created, and on destroy we are shutting down our executor TFLite as well as an app delegate, and here just an object class for creating a tag, file name format for saving the image, accuracy threshold, required permissions, as well as this is for model path. So whatever name you have given to your TFLite model as well as text, use that particular name. So yeah, that's it. Thank you for watching. Bye.